if I allow a line, the first one is, let me call this one with a green label. Let me call this one O, origin. Then let me call the end of this line moving towards A. So this line OA. Then this one will be line OB. We are still talking about what? Whole circle bearing. Whole circle bearing. Another name for the whole circle bearing is called azimuth. Azimuth. So I can say whole circle bearing, or I can just say simply azimuth. Note that one, not your notes. Now for line OA, we've seen how we measure clockwise from the north. What will be the nature of line OB? The same principle. We pick it from the north here, and then we move clockwise again until we meet the line. This angle from here all the way to there is the bearing, whole circle notation for the line OB. For the line OB. Let me bring in the third line. Then let that line go this way. Let me call the line OC. So this end is C. Typically, what it means is that the line should be pointing this way. They move from O and then head towards the point at the end there. So usually OB, OA for this one. O is the start point, A is the end point. This is OB. O is the start point, B is the end point. And they call it the start and then designation, or source and destination. Start and finish. So for line OC, what would we call the whole circle bearing? We have to go back here, always starting from the north. Then we will go around, go around, go around the line. So this whole angle here must be measured properly, and that is the bearing of line OC. Now, by the geometry, using the cardinals and the issues therein, a gauge. You have direction 0 or 360, direction 90 or east, direction 180 or south, direction 270 or west. Now, looking at the picture on the screen, let's put in some figures. What do you think will be the angle for line OB? You just look at the sketch. Would that angle be more than 180, or would that angle be more than 90?
So it will be more than 90, but less than 180.
Thank you. I think there's also another hand up. Let me try and go back to my screen. There's no hand here. Okay. This Jechi, Prince. Prince, you have your hand up. Okay. If he's not talking, John.
Yeah, so it will be more than 90, but less than 180.
Okay, Prince, you are on.
Okay, I support what my brother and my sister said.
Okay, thank you very much. What about the line OC? John.
So it will be more than 270, but less than 360.
Thank you. Abigail.
Sir, I was coming to say what he said.
Thank you very much. So you see clearly that The picture and the sketch always helps us to appreciate the magnitude of the angle involved, but the rule is still the rule. Don't mix it up with any standard system. All circle bearing or azimuth, you take off from the north, you measure clockwise. The angle you will travel from the north to meet the line, that is the bearing of that line. So we can put in some arbitrary digits or numbers now, just for the sake of example. So what we are saying is that OA, we'll write it this way. The answer for OA as a bearing will be 55 degrees. Note that I'm using only the degree, but I told you the other time, there are two subunits to the degree. We have the minutes, and then we have the seconds. But for simplification, the example here, I'm using only the degree. How many seconds make a minute?
60 seconds.
Thank you. How many minutes make a degree?
15.
Wrong. How many
Sir, 4.
minutes
It's 4.
Wrong. How many minutes make a degree?
Sir, 4.
Yeah, it's 4.
Wrong. It's 60. So 60 minutes will turn to 1. 60 seconds. 60 seconds will turn to 1 minute. 60 minutes will turn to 1 degree. Write that one to down in your delta somewhere.
So please come again.
Or we are not okay.
Sir, please, can you just repeat it?
I said when you are measuring angles, there are two ways of measuring angles, sense of the unit. There's one we call centesimal. That is used by the US people. They call it grade or graph. What we use, which is called a degree or degree minute second, is called a centesimal concept. Centesimal concept. That is where you go around in a circle and you cover a maximum of 360. But the degree has two subunits. The immediate subunit lower than the degree is minutes. And the other subunit lower than the minute is seconds. But these are the convention scales. 60 seconds will make 1 minute, like we know in time. But 60 minutes will make a degree. If it is time, 60 minutes will make an hour. Or we are talking about angular measurement. So 60 seconds is 1 degree. And 60 minutes, 60 seconds is 1 minute. And 60 minutes is 1 degree. So if you want to know how many seconds make a degree, it is movement of 60 and another 60, giving us 3,600 seconds is equal to 1 degree. Good. So OA is 55 degrees. I've not used the minutes and seconds, but the conversion I told you, keep it in your head. 60 seconds is 1 minute. 60 minutes is a degree. How do we write the minutes and seconds? This is a degree. A second to this would have been written as 0, 0, with 1 comma at the top here. This minute. Then you can have 0, 0 with 2 ticks. That is seconds. 1 takes minutes, 2 takes seconds. All right. So we're seeing a notice. So let me clear for the sake of space. Let me clear this one out. Good. So OA is 55. Using another arbitrary value, let's say this time I go for OB. Give me what you just said. I'm just choosing a figure. But the figure must be more than 90 and less than 180. Looking at the geometry, it's about halfway through. So let me take from here, the 90 to this one to be, let's say, 40. So that from here to here will be 50. This 40 will add to the 90 to give me 130. 130 degrees. Yeah, again, I'm talking about only the degrees. But you can have cases where you have minutes and seconds. Then we go for the last one. Let's say OC. Here too, by how we saw the pictorial effect, this is more than 270, but this angle is very small. Let's say 30 degrees. So that either 30 here with 60. 30 added to 270, you are going to get 300. Good. So what is the characteristic? You only see numbers representing the angle when you are in this system. OA is 55. OB is 130 degrees. OC is 300 degrees. But the rule does not change. If I want to sketch this three, I will have to always go and start from the north and turn clockwise. That is how I'm supposed to engage the diagram. You always start from the north. The north can be magnetic north, it can be grid north, it can be geographic north. It doesn't matter who it is. Because whoever is put there, you will only qualify the bearing. For instance, if the 0-360 is the direction of the magnetic north, all my values should be called magnetic bearing. If the direction of the north is the grid north, all my measurements will be called grid bearing. Please, up to this point, is everything clear? Full circle bearing. You take off from the north, you move clockwise. If you engage any anti-clockwise, your answer is wrong. These are the two key things when it comes to whole circle bearing. All right. So I'm going to do another sketch. This time, I'm going to quote some values, and then I'll use the values to do the sketching. And like I said, if you want proper work and with measurements, the protractor would have been our best friend. Measure with. All right. So now I'm going to clean up, or let me duplicate our slide so that in times of some clarification, I can always come back to see the same slide. Okay, so I'm on the third one, and I'm going to do some modifications. So I'm going to clean up. So let's go with this one up. Let me go with that off. Okay. Just leave our arrow so that we always remember that, and the whole circle you always turn clockwise. Then let me give you two lines. The first line that we are going to deal with is line OK. Line OK. We are starting from O as the source, and I'm going to end with K. That's the designation, the final point. Let's say OK is equal to bearing 165. How would the plot look like? We have another one we are calling OM. O is the start point, M is the finish point. And this one is equivalent to what? Sorry. Equivalent to 260 degrees. How do I sketch these two? And will be correct. O circle bearing station. How do I handle that? First thing is that rule says that the angle is measured from the north. Where is my north on the cardinal here? It is this direction. So if I want to see where OK will lie, it means from the north here, I have to be turning clockwise. By the time I get to 90, I have still not exhausted the angle. The angle is 165. So I will continue my journey. So in the end, this is how practically it's going to look like. From my north, I'll be going this way. Come to 90, it's not enough. Keep moving until you get to somewhere here. Why? Because here it's 180. This line is 180, and this one is 165. Not up to 180. So I started, I turned, but when I got close to 180, I stopped. Such that when I am able to eventually map or measure, this is how my line is supposed to be. With this hole here, this angle here, should be equal to 165. Then O will be at the start, and then K will be here. Give me OK. So OK, 165, it will be here. Later, we will see that this thing here, with this arrow here and arrow there, is a quadrant. With this arrow here and down here is another quadrant. With the 270, 180, another quadrant. The fourth one. But we are finishing the work on the whole circle bearing. Yes.
Hello. Sir.
I'm listening.
Hello. Please, with this, can you use the protractor?
Yes, you can use the
protractor.
Yes.
Okay.
You can use the protractor. What I'm trying to do is a sketch, but you can use the protractor if you want a more accurate method. What you do is that you will draw these two cardinals first. You draw these two cardinals first. And these two cardinals, what's the principle? They should be at 90 degrees to each other.
Okay.
So how would I use the protractor? In the case of this one, 165, you should always be flexible with your protractor. You should know how you can turn your protractor around, because the protractor can only turn in maximum 180. So you have to be smart to know how you arrange that 180 for various measurements. It splits, however, the cardinal directions into two major areas. But how you lay it will determine. If I am the one working with this data, because it is 165, it's coming from the north, it will clear 90 and enter here. You have to place your protractor this way. That's how you have to lay your protractor on the point. Such that the center here, the origin, will coincide with the center on your protractor. And then this line will pass through the zero of the protractor on this side. And then the 180 will also pass through the protractor on this other side. However, because our measurement is not up to 180, we are going to measure from the north, go on until you get to 165 on the dial of the protractor. I don't know if I've explained to you in any better way. Who asked the question?
So it's me.
Are you okay with it?
Yes, please. Thank you.
So you have to always be rotating your protractor to see which angle will best fit what you want to measure. Because for instance, if I didn't use this orientation and I put the protractor this way, when you come and lay it here, the protractor will run from here to there. It's exhausted. Yes, this is the angle you want to measure, and your start is from here. So you see clearly that this orientation to the protractor will not help my course. One. Neither would it be the same if I lay the protractor this way. All right. So having settled that, we've seen how I plotted the 165. All right. So let me put this protractor design off. And now we consider the second one, 260. Principle remains the same. From the north, you begin to turn clockwise. Now, if on the north I begin to turn clockwise, what will be my value I'm calling OM? 260. So this is how we begin. We take off from here, 10 clockwise. 10 clockwise. You come to meet 90. No, 260 is more than 90. You continue. Come to meet 180. No, 260 is more than 180, but less than 90. Then I begin to take off. Here, I don't take off to the end. Why? The end is 270. The value I want is 260. So if you are using the protractor, for instance, how much do you need to add to the 180 here to get 260?
80.
Good. So when you add 80 to the 180, you get 260, which means that our line is supposed to come somehow this way. So we go for it, and then we are supposed to be moving this way. And this is how our line OM is supposed to be. So you see clearly how the 260 and then 165 emanated in the diagram or sketch. Here too, if you were going to use construction, the use of the protractor to get your angle correct, how best would you lay the protractor? In this case, when you lay the protractor with the semicircle on this side, it will be exhausted because the line is going beyond. If you place it this way too, it will also be exhausted, so it will not work. The only way the protractor can work in this is always to look at the 180 concept. So majority of the angle is from this side all the way to that side. Good. So with the protractor, the best way to align so that we get our result is to use this side of the semicircle. Why? We are interested in the measurements from here to the line. That's what we are interested in. To find the bearing of that line. So I will lay the protractor this way. I'll lay the protractor this way. I'll start with my 0 here. And then I'll read onto this. But when you do that, understand that you came from here, which is 90 already. So it should be 90 plus what you are reading from here to there. And that will be given as 260 minus 90. That is 150. So from the 0 part of your protractor, you will read 0, 10, 20, all the way until you get to 150. Then you make a mark with a pencil. Then you use a pencil, the ruler to draw from the 0 to the mark. You can obtain or demonstrate that.
Hello.
Yeah.
Okay. Hello.
We are all listening.
Please, I'm not getting the explanation you are giving right now.
You're not getting the what?
You said 260 minus 19. I'm not getting it.
Because already you're listening, your network, you are struggling. I can tell from your question. The network is not helping you. So if it's not helping you, we'll talk some of them, you not hear. Yes, I'm listening.
The explanation that I just gave, you said 260 minus 90. Oh, I didn't get you right. Please, if you can come again
Yes,
with that.
somebody was asking how we use the protractor to get your angles right. And I'm saying that your protractor can only give you maximum 108 degrees. So when you have a case like this where you are measuring 206, how would you handle? How would you benefit from the accurate measurement of the protractor?
Then so you have to replace it from the 180 to the 270 direction.
The line. The line. So you can do that one too. Somebody can do this. You will consider this whole block here, this whole place from here, all the way to this at 180. So the person will not worry so much about that. He will now place the protractor this way. You will not do like I've done with this, but you rather place the protractor this way. Going back. Okay. He's going to place the protractor this way and start reading from 0 here. So he will think of 180 from 260, how much is left? And like one of our members said, you have 80. So instead of what I have done, I place it this way. But I needed to appreciate that I'm coming from here all the way to there. So if I am using a protractor from here, who is this one? That's 90 degrees.
Please,
So you
I
always
can't hear
what is the
anything
way to
from
learn with a protractor and the drawing?
dot's end.
Hello, Doc.
So you always have to be rotating the protractor. Yes.
Doc, please, I didn't get how you got there. 160 and 260. I'm finding difficult to get it. Is it that you the
I drew the cardinals. You were not watching that one. I said I've drawn the cardinals. This one, this horizontal line, and this vertical line. It creates 4 quadrants. 1 is here, 2 is here, 3 is here, and 4 is there. Each of them is 90. So if each of them is 90, then for 165, for instance, the rule says that from the north clockwise. I'm getting feedback from it. So from the north, you have to turn clockwise. That's the rule. If you don't follow that rule, you are not going whole sector bearing. You are doing your own thing. So from the north, when you turn clockwise, this is how you go. But 165 is more than 90, which means that from the north, you cross this line. So crossing this line means that you have cleared 90 degrees. And you will enter into this one, but you will not get to 180. That was for the 165. In the case of the second one, 260, rule says that from the north, so here again, we go from the north. And then we turn, by the time we touch on this line, we are in 90 degrees. You touch on this, it's 180. Then you go on, but you don't get to this one because this one is 270. And your figure is 260. So how do I get this part right?
Thank you.
This part right and measured. I have a protractor that has only maximum 180. So we are looking at how we can use the protractor to give us the measurement. Clearly, if you look at the diagram I'm dealing with, from here to here is 90. By the time you get here, it is 180 already. So somebody can decide that this is the angle I want to measure fully, get 260. But up to this stage, from here all the way to this line, it's 180. So I can orient the protractor this way. When I orient it this way, I'll come and place the center of the protractor here, this one over this point. So it's to take off from here and go this way. Then all I have to do is that I already have 180 in the back. 180 is from here all the way there. So how much angle do I add 180 to give me 260? And the answer is 8. So what it means is that when I bring the protractor and I'm having it this way, then from 0, I can turn until I get to 8, then I stop and I mark it on the edge of the protractor.
Hello, hello, sir.
Yes.
Please, sir, can you increase your cursor so that we can see well? Because the cursor is too small. Sometimes when you are talking, we don't see where the cursor is.
So the point now I was saying is that here is the numbers that tell you where you are going, but the rule is always saying that come from the north. You always take off from the north and you turn clockwise. Clockwise movement means you go this way. That's clockwise. So you always come from the north, turn, go to meet the line. From the north, turn, go and meet the line. From the north, turn and go and meet in the clockwise fashion. All right. So is it clear now?
Yes, Doc. Thank you so much.
Good. So when you are using the protractor, you always have to see how you flip it, how you rotate it, and then which angle it will fit easily for your construction. Because the limitation with the protractor is that it can only measure maximum 180. So if you have a figure that is more than 90, more than 180, more than 270, you have to be smart in how you arrange the protractor to work for you. But then there are also other guides, like what I've just showed you. If you drew your cardinal well, if you are drawing a cardinal well way and that way, then between any two lines, it's 90 degrees already. Any two lines, 90, any two lines, 90, any two lines, 90. So when you have a figure more than 90, you can track where the 90 should be because you are starting from the north. And then ask yourself, how much do I add to the 90 to get my figure?
Hello.
Yes. So can I
Hello.
proceed now? Mm-hmm.
Hello, sir.
We are listening to you.
Doc, my hand had been up for for so long. My hand is paining me. Please,
I am on the other side
before.
of the slide, so I'm not seeing your hand listing on the interface. Sorry about that.
Oh, okay, okay. Sir, please, before you gave us the second question to try our hand on, uh,
Mm-hmm.
uh, you gave a theory. I didn't get you well. You said 60 seconds is equal to 1 minute. That part, just that part, I didn't get it well. Please, can you repeat that part for me?
The 60 seconds, 1 minute has nothing to do with what we are doing currently.
Okay.
You
If
mix
only
the
we
things
not
up.
that.
If you mix the things up, you run into trouble. That's
Come
the way.
again. With this one, I do understand. I'm okay with it. But that one, it was that time that I raised my hand to ask the question, but since you didn't say it.
Okay. The 60 minutes and issues came about when I said the angles that we read is not only degrees. There are two more subunits. One is called minutes, one is called seconds. And
Okay.
what is the rule? 60 seconds will give you 1 minute,
Yes.
and 60 minutes will give you 1 degree.
Okay.
So when you have 3,600 seconds, it is equivalent to 1 degree.
Okay.
And that is so because 60 of the seconds will give you a minute, and 60 of the minutes will give you a degree. So when
A
you're coming
degree.
from seconds all the way to a degree, you need 60 by 60. That is why you need 3,600 seconds to make a degree.
Okay. Thank you.
Is it clear now?
Yes, sir.
All right,
Thank you.
you're welcome. So we've seen how the rule applies. Whenever it is whole circle, your thinking should be from the north, I will turn clockwise. The angle I turn to meet my line is the bearing of that line. Good. So now we are changing over from the whole circle bearing to the reduced or quadrantal bearing. Then we will look at how we move from one of the systems to the other and back. Very important. We are doing this because in surveying and in angular measurement, you may apply both systems. Some questions will give you information in the reduced bearing notation and ask you to find the corresponding whole circle bearing. Some questions will put the information in the whole circle bearing, and you are supposed to determine the corresponding reduced or quadrantal bearing. Good. So now we go over to the other side, reduce bearing, the second system. To help me do the demonstration, let me duplicate this one again. And this time, let me clear shift here. Now you watch what happens to the reduced bearing. The name reduced is there because here we deal with quadrants. And in a quadrant, you cannot measure an angle more than 90 degrees. Again, relating to our cardinal concept, when you are in the reduced or quadrantal bearing, your definition of the bearing is a mixture of numbers and letters. The letters define the quadrant. The numbers tell us the angle involved. 2. In this system, angles are reckoned either clockwise or anti-clockwise. So What is the issue? When you are in the quadrangle, the first one was the whole circle. So let me just draw a circle for us to see the connection. So I'm talking about circle concept this away. So that's the circle. Then now we come to the quadrant. So what happened? The circle is split into 4 equal parts. And these are the labels. Direction to this side is called the north direction. Direction to this end is called the east. Direction to this side is called the south. And direction to this side is called the west. Giving us what we call the cardinal direction. Cardinal direction. So here, and with the quadrant concept, this is the first of the quadrants that we can speak of. First quadrant here. It is the area trapped by the east arrow and then the north arrow. East arrow, north arrow. Then this is 2. 2, quadrant 2 is defined as the intersection. So our first quadrant, meaning that in this first quadrant here, in this first quadrant, the angle here, 90 degrees. The angle here is another 90. The angle here is 90. And the angle here is 90. So irrespective of your quadrant that you belong to, the angle involved in the measurement cannot go beyond 90. So that. I also said, with this quadrant concept, the framework is on the quadrant. So depending on where you are found in analysis, angles can be measured clockwise or anti-clockwise. It is allowed under the quadrantal or reduced varying notation. So we continue. And clearly, this will be the third quadrant. And this will be the fourth quadrant. Are there any questions up to this point?
No, sir.
All right. So our numbers have dropped. We are having around 6. I hope they don't come back later with an excuse of not understanding. Okay. So good. So we have quadrants 1, 2, 3, and 4. Each maximum value is 90. But there's something that is clear. Look at the letters well. When you are here, quadrant 1, you are defined by the north direction and the east direction. When you are here, quadrant 2, you are defined by the south direction and the east direction. When you are here, is quadrant 3, you are defined by the the west direction and then the south direction. And when you are in quadrant 4, you are defined by the north direction. West. So when you're in the first quadrant, your language is as follows. You define bearing according to this format. Your bearing is always stated according to this format. When you're in the first quadrant, let me use green or purple. Which one will come nice? These are green. When you are here, this is how you call bearing. It's north, alpha degrees movement towards the east. If you are in this quadrant, that's the language, how you call bearing. When you are in this quadrant, this is how you reckon or call bearing. South, theta, east. That's quadrant number 2. So let me put in the sketch. Suppose I have this line. Suppose I have this line to measure. As long as it is a reduced bearing notation, this is how my general statement should be. Who is the alpha here? The angle from the north to the line. The angle from the north to the line. So, what can be alpha? You look at the figure. Halfway of this space is somewhere here. Our line is somewhere there. So it is more than 45. It's heading towards 60 or 65 or whatever. So let me use an arbitrary value of, let's say, 62. So when I'm stating the bearing of this line, this angle should be 62 here. One. It should read as 60. It should read as 62. If it reads as 62, I'll come and quote it as north. 62 degrees. Difficult to do online with the mouse. So you're talking about 62. Then you add the E. So we see it as north, 62 degrees east. What is the interpretation? From the north, 10 clockwise, move an angle of 62 degrees to meet the line. And therefore the bearing is north, heading towards the east, an angle of 62 degrees must be captured or 10 or measured. That is that. So let's say a second line which is coming from the second quadrant. Here I didn't put a label to it. I could have done OA or OK or OP or whatever it is. The start is the origin, the end is the end of the point here. But let me take a second line. So in quadrantal, let me go with this purple. I hope it comes out clear and clean. So let me have this. That's my line. You can call this one O. Origin, you can call this one K or M or T. So this is the line you want to determine is bearing. Okay. So with this line drawn, what is going to be the quadrantal bearing? Already I stated to you that this is how you call that one when you are here, second quadrant. You start from the south and then you turn to meet the line. Now, watching the diagram, if I'm going to start from the south and tend to meet the line, will my movement or my turning, which is defining how I measure the angle, clockwise or anti-clockwise? If I have to start the measurement from, okay, I have Azuma on the line, his hand is up. Azuma, you have your hand up.
Yes, it's anti-clockwise.
It's anti-clockwise. Sheila, I saw also your hand up.
Yes.
Say anti-clockwise.
Thank you. So clearly you see that in this system, movement can be clockwise like we saw for the first one. And the movement can also be anti-clockwise. It depends on where you are. There's a pattern, and if only you can remember, it works. The second quadrant and the fourth quadrant, they are all anti-clockwise movements that are involved with the angle we need. They use the south to the east this way, anti. When you are here too, you start from the north and turn this way towards the west. So that's also anti. So the second quadrant and the fourth quadrant, angular reckoning is anti-clockwise. All right. So now looking at this diagram, what can we say? This line seems to be about halfway between these two axes, the eastern axis and the southern axis. So the angle here, which is 90, is being split about the halfway. But it's not exactly halfway, because halfway would have come somewhere here. So let me adapt a value of, for instance, 40 degrees for this angle here. So what would I write as my answer? My answer will be captured this way: south 40 degrees east. And this is how the sketch will look like from the south, because the language is always from the south, go towards the east. So from the south, I'll turn towards the east. And this value here should be 40 degrees. But the bearing will be stated as south 40 degrees towards the east, or south 40 east. Yes.
Yeah.
Yes. So are we picking it? So you see that one is anti-clockwise. So it's south 40 degrees towards the east. The angle is not this one. Angle is the other one. Not here. The angle is this one, not there. The angle is from the south towards the line, heading along the eastern corridor. So that's why you have S, theta, E. All right. So we go to the third quadrant. Third quadrant, the language there is south, head towards west. So the general writing is this way. South, I want a symbol for my angle. I've used alpha, I've used beta. Okay, I want to use phi. When you're in the third quadrant, that's how you pronounce bearing. South is your angle, and then the bearing comes. So let's put a line there and let's see how the measurement will come out. I'm using green now. If this is my line, I'm supposed to call the bearing in this form, S 5 degrees and then west, which means that I have to go and begin the measurement from the south. I'm going to begin the measurement here. And how do I head towards the west? I have to be going to this end. This is the angle I need if only my line is the quadrant. By the sketch, this is certainly more than half the space here. So suppose I give it, let's say, 70 as a figure involved. Then we are going to have a coast like this, south 70 degrees west. In that case, the 70 will be this angle here from the south. This one will be 70 degrees. So every quadrant has its way of calling out the quadrant. But in the listed way of calling the quadrant, some of the angular movements are positive. All right. So in the third quadrant, we've seen it as south 70 degrees west. So here, how was the angular movement? Is it clockwise or anti-clockwise?
Sir, clockwise.
Okay. Okay. So the pattern is coming out and clear. If 2 and 4 are anti, then 1 and 3 are clockwise. Okay. So we get to the fourth quadrant. And I'll place the line there. I've adjusted all my colors now. So suppose this is my line. This is my line in the fourth quadrant clearly defined by the two letters north and west. Measurement of the angle will be from here north and go this way.
So I can't see the diagram again. Okay, thank you. It has come.
So I'm going over again. We are in the fourth quadrant. It is between the north and the west. Movement is from the north towards the west. So from here, we'll turn this way. This angle, probably at a value of, let's say, 35. So when we are here and in the fourth quadrant, the language is going to be as follows. From the north, move towards the west by how much? 35 degrees. So the bearing will be stated as north 35 degrees going towards the west. So we have this, we have to complete it. It's north 35 degrees west. North 35 degrees west. So this is where you usually have the difficulty. Appreciating every quadrant and the rule for the quadrant. So we see now all the four quadrants have been engaged. So the difficulty when it comes to the reduced variance notation is your ability to appreciate every quadrant and the rule for the quadrant. Whole circle, we said measure everything clockwise. Quadrantal, it depends on the quadrant. First and third, clockwise. Second and fourth, anti-clockwise. Good. So now we see the two systems. How then do we convert from one form to the other? And vice versa. At times, okay, Sheila.
Thank you, Doc. Doc, please. So, this particular reduced berry in examination, will you be giving the figures to fix in whether in first quadrant, second, or you deduce it yourself? Thank you.
Usually the question has to come with some level of information.
Oh, okay.
And then based upon the information given, you deduce the other. For instance, if it's about converting from one form to the other, we must give you the information pertaining to that particular form fully, complete. Then based upon that, you convert to the other form.
Oh, okay. Thank you so much.
All right, so we want to look at some examples. Now I'm going to start with the examples where you are giving whole circle bearings and how they will impact or be caused when you are in the other step. So let me duplicate again, and then let me clear my board. I always tell students that the best way to deal or handle this quadrantal is to sketch it if you can sketch it. Picture is more PowerPoint than the formula. Okay. So let's start with the first one. Suppose you have a line. Suppose you have a line called AB. And we say it has a whole circle bearing of 89 degrees. And you want to find the corresponding quadrantal bearing. Here, I mentioned whole circle bearing. If I didn't mention, you could have still detected the whole circle bearing because the value was given as 89 degrees. Finish. No letters were added to the value.
Hello.
Yep. I'm listening.
Hello.
Yes.
I can't hear. I can't hear you.
Network.
I can't hear you well.
You can't hear me well.
It's not. It's not okay.
Okay. So if the line is AB and it is 89 degrees, this is whole circle bearing. What do you think is going to be the corresponding quadrantal bearing? John, your hand is up.
Yes,
Where is the A? Where is the AB
I want
on
to give it
the?
a try.
Come again.
I want to give it a try. Oh.
Okay.
So it will be the same 89. So it will be north 89 degree east.
Thank you. It's correct. So first, I want to go by the sketching concept. Forgive me and let me clean this other aspect of the numbering, as if you are getting used to the quadrant concept. Now, this 1, this 2, this 3, this 4. So if I was doing the sketch, then I would have gone for this as such. This whole circle. So what it means that from the north, I send 89 is not 90, but it's very close to 90. So from the north clockwise, I go very close. All right. So my line should be somewhere here. Such that this angle, 10 clockwise, is 89. If it was whole circle, here should be 0 or 360. The east should be 90. Here should be 180. Here should be 270 because under whole circle you don't introduce letters. All right. So these are 89. Whole circle, I move from the north until I clear 89 degrees, close to the 90, and this is how my line will be oriented. In this oriented design, A will be the origin, and B will be the destination. Qualify the line AB. Qualify the line as AB. Now, when I change the language, so if I'm both circles, I would have written here 0 degrees or 360. I would have written here 90. I would have written here 180 for the sake of the sketch. Because the letters are not fast. I would have written here 270. So when you come to the quadrant, here we said for 0 or 360, 90, 180, 270. This is for whole circle bearing. When it is quadrant, I cannot use the numbers. I will use the letters. So in the quadrant, this is north, this is east, this is south, and this is west. Now my sketch puts me in this quadrant because the north is there and the east is there. So I am inside here. That is first quadrant. What is the language of first quadrant? North, the angle involved, we are calling it alpha, and then east. We said the angle is reckoned clockwise. So from the north, we have to turn this way. We don't have to turn that way. Turn this way. So when you now look at this same line, AB, the 89, and in the quadrant, the north is there, the east is there. From the north, we move. That's the meaning of the definition of the bearing. From north, move towards the east. If I'm moving towards the east, then I'm following this line. That is 89. So what was going to be my answer is north 89 degrees east. All right. So look at the whole circle. AB 89. Quadrant are the same AB is north 89 degrees east. Because in the reducer quadrant, you always stay in your quadrant. Don't go to the start, resolve somebody in the other quadrant. So when you're in the first quadrant like this one is saying, what's the language? It's north alpha degrees east. So I give you a second question. The second question, we are looking at another line, OD. The line is OD. And the bearing is 205. What do you think is going to be the whole circle bearing? Sorry, the quadrantal bearing. Okay. Sarah. That was a mistake. Your hand was up.
Now, south 205 degrees east.
No. The first way said 205 degrees east. East is only one letter. It cannot qualify a quadrant. You need 2 letters.
Oh, okay, sir.
John. Victoria.
Hello, sir. We get south 15 degrees west.
South 15 degrees west. Good attempt. I made out the calculation. It's not 15 degrees, it's 25.
Okay. Okay.
You see it now?
Yes, please. I didn't do the subtraction well.
Well, okay.
Thank you.
You're welcome. So let's duplicate again and then see how we edit clean to work on that. So we are done with this one. Done with this. All right, so we are looking at OD. It's 205. By whole circle definition, what it means is that from the north, I have to turn clockwise. So the whole circle definition. Now, when I turn clockwise, this is 90. It's more than 90. I go 180. It's more than 180. By how much? But definitely, it's not up to 270. So by how much out of the 180? You subtract 180 from this, you get 25. So what it means is I will enter a bit and then stop. So here will be O, signify at the beginning of the point. Here will be D. Can I even put arrows here to show how your movement is? But this will be 205. And 205 will be seen as 90 plus another 90, 180 plus 25. So this angle here is 25. Good. So we are in the third quadrant, and the language of the third quadrant is saying that south, your angle comes, and then west. So there should be 2 letters to tell us the quadrant, not 1. And from the south, you'll be heading towards the west. So it's clockwise. Of course, we know it's in the third quadrant, and we said the third and first movement is clockwise. But the 205 is from here, the north, all the way to this point, 205. But if this line here is 180, so what is this space here? It becomes 205 minus 180, and you get 25. So our final answer would be south 25 degrees, heading towards the west direction. Please, is it clear? The sketch always provides you a better picture of the scenario than trying to quote or use formulas. All right.
Hello.
Yes.
Yes. Where is the 25?
The 25 is here between the red
The
line.
SW.
Between the red line and the line of design. This line OD. We said from here, 205 is the whole circle bearing. So if you're in that system, I must start from the north and go clockwise. Now, when you are going clockwise, by the time you are here, it is 90. By the time you have moved to this one, it's 180. So how much are you left with to get 205? It's 25.
25.
How did you get that one? You subtracted them where you are now, which is 180 from 205, and you'll be left with 25. In the diagram, where would that 25 be? It will be between this line and then this line. Is it clear?
Okay.
Please, is it clear?
Thank you. Yes, please.
Okay. So the 25 is here. And then if you're in the third quadrant, because clearly with the 205, we are inside here, it's third quadrant. If you are dealing with the quadrantal concept and you are here, the language is south with the angle and then west. Which angle are we talking about? The measurement from the south to the line.
Okay.
The measurement from the south to the line, and that is 25 degrees.
Okay.
Is it clear now?
Yes, please.
All right. So we've seen where we have two examples. They were whole circle bearings. We've gone to the quadrant. I'm going to give you two more, which are quadrants, and then we find the whole circle bearing. Sheila.
Doc, please, I'm confused with the 205 and then the 25.
Yes, because you are not watching the diagram.
Doc, please, I'm watching.
If you don't watch the diagram and you just look at the figures and listen, you run into confusion. if you are measuring 205 from the north here and you are going clockwise, you traverse through this angle. Here, by the time you move and get here, you have cleared 90. By the time you move and get here, you have cleared 180. You agree?
Yes, Doc.
So if you have cleared up to this point 180, how much is left out of the 205 to show?
Okay, I've got you now. Thank you.
So you are left with 205 minus 180, and that will give you 25. So the 25 is the extra of the angle beyond the 180. Beyond the 180. This is where we are. Yes.
Thank you so much.
Interestingly, that 25 will also be counting for us when we come to the quadrant. Because in the third quadrant, the language is south, the angle, and then towards the west. So when you are here, it is from the south towards the line, the angle you measure. So this south, red line, move towards the line. What is the angle involved? It's in this small space, and that is the 25. So when you are writing the statement for the bearing, you write that south 25 degrees west.
Thank you.
Is it clear now?
Yes, please. Thank you so much.
It's quite simple, but at first it looks confusing. Later on, you may have to reflect upon it generally again and then sit down and then look at the issues again and to pick it up. So the first of my two examples is that there are two lines. Let me clean again this one. So I'm proposing another line. The line is called QT. The bearing in quadrantal notation is north 38 degrees west. The first question is that looking at the quadrant concept and definition, is it the first quadrant, second quadrant, third, or fourth?
Sir, please, fourth.
Fourth.
Fourth quadrant.
Kind of quadrant. Okay. Now, for the definition, how would I sketch it? From the north, I have to be heading towards the west. That's the general statement. From the north, move towards west. Is that one clear?
Yes, sir. Anti-clockwise. Yes.
Meaning that the angle is what? Reckon anti-clockwise. So how do I move from the north towards the west by an angle of 38 degrees? It means my line somehow should be here. My line should be somewhere here, such that when I move from here towards the line, I will get 38. Because the definition said from the north direction, move towards the west. But your angle in your movement should be 38 degrees. All right. So are we clear with the north 38 degrees west?
Yes, sir.
And the sketch that I've done. So who is the 38? This small angle here is 38 degrees. But this is quadrantal. We are nice. We are happy with it. How do you get whole circle bearing? Rule says that we should move from the north clockwise. John, your hand is up, right?
Yes, sir.
Okay. What do you have for us?
That will give us 322 degrees.
322 degrees.
Yes, please. 322.
322. Okay. Who else has seen that same picture?
Yes, sir, I got it.
Thank you. So how do we proceed?
So,
How do we proceed? The line is there. Q will be here. Q will be at the start here. What we call the origin. Q will be there. And then at the end here, T will be here. But this time we are interested in whole circle bearing. And the rule in whole circle bearing is that from the north, go clockwise. So now, let me use a color that will help us see. Yellow is not good, but let me see what else can I bring to bear. Maybe black. Maybe. So now, watch what I'm doing, trying to implement the definition of whole circle. So watch, I'm coming from here, north. I have to go clockwise because I'm doing whole circle. So I go this way, clear that, clear that, clear that, come to the line. This is whole circle bearing. But the rule says that from the north, turn clockwise. So how much have we traveled? Don't forget, look at the small circle here. When we go around, what is the angle we clear?
so 330.
What is the angle we clear when we go around?
322.
No, when
Three,
we go around.
360.
360. Thank you. But you can see clearly that whole circle says I should do this work this way. But this plus this will give me the round, isn't it?
Yes.
Okay. So if I call this angle A, it means A plus 38 should be equal to 360 degrees. True or false?
It's true.
All right. So if A plus 38 is equal to 360, then what's A? You subtract 38 from 360, and rightly as Sheila and the other gentleman said, you will get 322.
22.
322. So QT is north. QT is north 38 degrees west when you are talking about quadrantal bearing or reduced bearing. But the same QT in whole circle should give us 328.
It's 22, right?
22, sir.
22 rather, not
22. Thank you, thank you, thank you. That's good. It means you're following. All right, so 322 is the whole circle bearing, while quadrantal is north 38 degrees west. The last one, so we can close. I'm left with the concept of back bearing and forward bearing. I will add that one when we come in on Sunday. But for the two systems and moving back and forth, this is our last example for practice. And we can all go rest. Suppose you have a line, and the line is PK. Meaning you are starting from P and ending at K. And the bearing is in the quadrantal. South, 18 degrees. I want to make it a bit complicated for you. 20 minutes. East. South, 18 degrees, 20 minutes east. What will be the whole circle bearing notation corresponding to this quadrantal notation? In the first place, the quadrant that was stated, is it the first, second, third, or fourth?
So second.
Okay. So it's the second quadrant. Great and perfect. So when you put in your sketch, the sketch should suggest that from the south, you move towards the east. Is your movement going to be clockwise or anti-clockwise?
Anti-clockwise.
Good. So you are going to move anti-clockwise, an angle of 18 degrees, 20 seconds.
Anti-clockwise.
Thank you. So from that, duplicating into the last one and cleaning the data of those I don't need. What do you think is the whole circle bearing? Do your own analysis. And if you are successful with the answer, let us know. Yes.
Please, you said the bearing is south 18 degrees, 20 minutes.
20 minutes.
Okay.
Yeah.
So I had 161.7 degrees.
161.
0.7 degrees.
0.7. Wow. Okay. Sheila, your hand is up.
So I have 162 is 70 seconds.
70 seconds. Okay. Please let me write the issues down. Sheila, your hand is up. Okay.
Yes, I have 162, 70 seconds.
Okay. So let's start with the last one, then we go to the other two. Sheila, you are saying you have what?
162, 70 seconds.
162, 70 seconds.
Yes,
Hey,
please.
are you sure 70 seconds or 70 minutes?
70 minutes.
70 minutes. Okay. All right. So that is your suggestion. We will see whether it is correct or wrong. Who gave the second one? And what was your value? Then someone also gave us the first answer. I forgot it.
Sir, it's 161.7 degrees.
161.7
degrees.
So where is
Yes,
your
sir.
0.7 coming from? It's not a wrong format, so, but we've not discussed it in class yet. So where is your coming from?
Sir, I considered 60 minutes equal to 1 degree, and having 20 minutes. When you divide the 20 by 60, it means you are going to get 3. So I made 180 minus 18.3.
Okay. All right. Okay.
And I had
let's all go through that so that we can close with it. First, I want to plot it. So from the south, I move towards the east. A value of 18 degrees 20. So this is the south. This is the east. So I have to go anti-clockwise. But I have to clear angle 1820. So 1820 is roughly like 19. All right, where would that be? I'll move from here a small angle this way. This one is a sketch, so I've not done the plotting exactly. And then my line is supposed to be coming out from here somehow. Okay. So that's how my line is supposed to be. But it says that south, 18 degrees 20 towards east. So south, and from there, 18 degrees 20 towards the east. That is it. Whole circle will mean that I am supposed to come from the north, isn't it?
Yes, sir.
The
Yes,
whole
sir.
circle says I should come from north. But that's the definition there. So from north, I turn, until I meet my line. So what's the connection? Look at this small piece. Look at this big one. Look at the line north, south. North, south is 180, right?
Yes, sir.
Good.
Yes, sir.
And this is supposed to be 1820, right? From the sketch I did for this one.
Yes.
So what is the concept? You see that the small one, 1820 plus this big one should be 180. So let me call this big one alpha. What it means is that 1820 minutes plus alpha should be equal to 180. So 180 is degree. For the sake of the minutes that has appeared here, let me introduce another minute issue. By this time, I'll call it 0. So 180 degrees is the same as 180 degrees, 0 minutes. Do we agree? So what
Yes,
then
sir.
is alpha? I have to move this 1820 to the other side. It is plus here. When you move it, it's going to subtract. So let me fix it under the 18. Sorry. So this one will be 18 here. And then here will be 20. Then I'm going to do the subtraction. So let me clean this one because it's no more in the equation. So we have to subtract rather from this one. Like we do for normal math. 0 minus 0 will be 0. 0 minus 2 is not possible, so I'll go to borrow. When I borrow, it's a degree. So when I take 1 and I'm converting to a minute, 1 degree will be equivalent to 60 minutes. So what does it mean? I take 1 degree from here and bring it here. It's going to be 60. And here will be left with 179. Hello?
Hi, sir.
Are we seeing the picture?
Yes, Doc.
Yes, sir.
Good. So I borrowed 1 degree and I converted it to minutes. But the conversion is that 60 minutes is a degree. So when you take 1 degree and you are going to minutes, it becomes 60. So the 180 degrees can be written as 179 degrees, 60 minutes, and it's correct. Although we don't use the 60 minutes as that convert, but for the mathematics, it's still correct. Then I subtract 60 minus 20 is what? 4, isn't it? Then what is 179 minus 18? 1, 6, 1.
No. Hello.
Yes.
Hello, Doc. What was the 179?
It's because we started with 180 here. We started with 180 here. And the 180 is all degrees. Now we are subtracting a figure that has both a degree and a minute. 18 degrees, 20 minutes. So it will be fair if you can express the 180 as a degree and minute. So how do we do that? We borrow 1 degree from 180. When you borrow 1 degree from 180, you'll be left with 179 degrees. And then the 1 degree you are taking and change, we change into a minute, it becomes 60.
Okay.
So the 180 degrees will now read as 179 degrees, 60 minutes.
Okay.
So is it clear now? Okay. So the 180 can be rewritten as 179.60. But in the second one, which is the 179.60, it's nice because what I'm going to subtract has components for minutes and components for degrees.
Yes, sir. So, sir, please,
So
now
60 minus 20, yes.
I'm asking that. So the problem from the 180 when it became 179. Now we are not using the 180 again.
So once you borrow 1 from the 180, it will become 179. And that 1 is converted to minutes. You get 6.
Okay.
So the 60 part, when you subtract 20, you get 40. Then the degree part, you have 179 minus 18, you get 161.
Okay.
So the answer is 161 degree
Degree
40
40 seconds.
minutes.
Oh,
The first level
40
under
minutes.
the degree
Okay.
is minutes. The second one under the minutes is seconds.
Yeah, so
So the first one, we missed it. Killer. The second one, it might be correct unless I check. Because if I want to convert to full degree, it has to be written as 40 over 60, and then I convert to decimal, which gives me 4 over 6. But I wonder if that one is 7. All right.
Okay, Doc, thank you. But Doc, if in exams and I'm so close to the answer, will I be given the mark?
If it's an MCQ, you can't be so close. You have to get it right.
Well, just let one mark. Oh.
Yes, that one mark is a problem.
Please, sir, is it necessary to change the seconds to degree to, or you can just leave it like as we had it as the 40 minutes?
So that's what I'm saying, that somebody mentions 161.7. Yes. I've not done the investigation for that. It's another way of writing star for angle. We call it decimal degree. And the one we have been working with, we call it degree minutes seconds. So there are two styles way of writing the angle. But what I have not done is I have not verified whether the 0.7 is correct.
okay.
Ah,
Oh.
good. Are there any questions before we end?
Doc, in the exams where they give you two figures, as you give us 18 degrees, 20 minutes, and that of 8 and 9, do you need to illustrate it in different diagram or one diagram?
Oh, you can say use the illustration with only one diagram. The only thing
Okay.
like I did, what I did here, I wrote the whole thing in the middle. And once you have everything in the middle, that's the value. So your sketch should still be possible.
Okay, thank you.
Uh-huh. You're welcome.
So there. Look,
Yes, yes.
the 161 is from the north to the south. 161 40. 161 degrees 40.
Yes. So it's 161
40
degree 40 minutes.
minutes. Okay. So that is from the north to the south there.
Hello, sir.
Yes.
Please, sir, this one we are begging. We have done the note all right. As we are teaching, some of us are still taking the note. But, sir, we need the slides also to help us. So we beg you, this one, help us. Already, as you said the course is difficult a little bit. And we are taking notes, but still, we beg, we need the slides.
Fair enough. I don't think I've said you will not get a slide. But I cautioned you that the slides may not be sufficient compared to what you listen in class and jot down.
Yes, sir, we understand. We have the note all right, but we need the slides also to help us, and our time is too close. So we beg you, if we can get it, maybe in the next day or 2 days, I said we'll be very happy. We beg you.
Okay.
Maybe there are no other questions, then we say thank you all very much for holding on for 2 hours, some minutes. And that I'm sure when the slides come in and we meet on Sunday, to have a smooth transition from that point into the rest of the discussion, which is dominantly going to be in cartography. But of course, you have to bring your masters along. So we'll try some traverse plots where we'll be using the protractor, we'll be using the ruler, we'll be plotting bearings.
Okay.
So you can use the opportunity to check from YouTube and other places how we use the protractor and for construction of various bearings. Do some learning before you come. And that you struggle to catch up, see expansion and other things. If you are taking everything raw Sunday, you will struggle. So just do some reading around, go to YouTube, you see plain illustrations on how we are able to measure with the protractor. All right, so thank you all very much. And we meet on Sunday. Have a good night and a good night. Bye-bye.
Okay, thank you,
Sound
Doc.
sleep. Bye.
Thank you.
Bye.
Mr. Kunedu.
Hello.
Boss, the calculation, this is how I did mine. I subtracted
Okay.
180 minus 80. That gave me the 162.
With the calculation.
Yes. Then I subtracted 90 degrees. I subtracted 20 from 90 degrees. That gave me 70. So that this calculation we did, I get it well. Now he got the 40 and then the 161. That's why I had 162 over.
Okay. So, as he said, 1 minute, 1 degree is equal to 60 minutes.
Yes,
For that one, you do understand that.
yes, I understand that one.
Yes. So, looking at the figure, you see, with the 20 minutes, it's left with 40 minutes to make a degree.
Okay,
You get
okay.
it?
Which is 60 minutes.
Do you get
Is
it?
there 40 minutes? Is there 40 minutes out to the 20 to give you 1 degree, which is 60 minutes?
So it's 18. The actual figure is 18 degrees 20 minutes.
Yes.
Uh-huh. So for us to get the difference, and considering the law 1 degree equals 60 minutes,
Yes.
so it will be left with 40 minutes to make up,
Okay.
to
The
sum up
60.
to the 1 degree.
Okay. All right. That's my confusion.
Okay.
Too much. I
You're
understand.
welcome.
Thank
You're welcome.
you.